Hello everyone, and welcome to today's video, where we'll be looking closely at operating systems. We'll cover various types of operating systems, including distributed, embedded, multitasking, multi-user, and real-time systems. We'll also discuss BIOS and device drivers and virtual machines. Let's get started. First, let's talk about distributed operating systems. These systems are designed to manage communication with hardware and can coordinate the processing of a single job across multiple computers. This means that users can run programs that utilize data or resources from other computers, such as processor time, memory, and input and output facilities. The operating system passes instructions between computers to distribute tasks, giving users the illusion of working with a single powerful processor. One key point to note is that programmers do not need to modify their training or programs for distributed systems, but they have no control over task distribution, which is entirely managed by the OS. Next, we have multitasking systems. These systems allow a single processor to appear to perform multiple tasks simultaneously by efficiently scheduling processor time. For example, you can read a document, browse the web, and listen to music all at the same time, while other processes run in the background. This efficient use of processor enhances the user experience by enabling multitasking. Now, let's discuss multi-user, multitasking systems. These systems are often found in environments like universities and large businesses, where powerful computers known as mainframes are used. Multiple users access the mainframe CPU through their terminals, each receiving a time slice to perform tasks. Each terminal can run multiple processes, allowing for efficient resource utilization and task management. Moving on to mobile operating systems. These are essentially computers with multitasking operating systems. For example, iOS on the iPhone can run multiple apps like Notes, Calculator, To Do, and phone apps simultaneously. Mobile operating systems are tied to specific hardware, such as Android and iOS phones. The low-level proprietary OS handles hardware and special features like cellular connectivity and Wi-Fi, while the main OS manages the user interface and applications. Let's talk about open source operating systems. Android is a prime example. It's an open source OS based on Linux and owned by Google, used by major device manufacturers like Samsung, Motorola, Dell, and Ericsson. Android allows for significant customization, enabling manufacturers to fine-tune the OS for their devices and add features or user interfaces to enhance the user's experience. The interface and available apps can be a major selling point for devices using Android. Next, we have embedded operating systems. Many devices in your home have an OS and run simple programs. Embedded OSs have minimal features with application programs stored in ROM and very limited RAM. The user interface is simple and minimal, suitable for household appliances. Examples include devices like microwaves washing machines, and smart thermostats. Now, let's discuss real-time operating systems. These systems must respond extremely quickly to inputs and may need to handle multiple inputs simultaneously. Real-time operating systems are often used in safety-critical environments, such as medical devices, industrial control systems, and automotive systems. They have fail-safes to detect and respond to hardware failures with hardware redundancy to ensure crucial components are duplicated in case of failure. Let's look at a case study. The Therac 25. This was a radiation therapy machine from the 1980s. It had a real-time embedded operating system. Unfortunately, programming errors led to incorrect responses to real-time inputs, resulting in fatal radiation overdoses for several patients. This case highlights the importance of rigorous testing and validation in real-time systems, especially in safety-critical applications. Here we have another case study of a Patriot missile defense system failure. You might want to pause the video for a moment and have a look at this case study also. Next, we have BIOS, which stands for Basic Input-Output System. BIOS is stored in ROM and is responsible for booting the computer at startup. It initializes and tests hardware components and loads the operating system into RAM. Let's talk about device drivers. Drivers are programs that provide an interface for the operating system. This is to interact with hardware devices. They are hardware dependent and OS specific, allowing the OS to control devices like speakers and graphics cards without needing to know the hardware specifics. Finally, let's discuss virtual machines. Virtual machines are software that emulate a machine, allowing one operating system to run inside another and emulate different hardware. They can execute intermediate code, such as Java bytecode, and emulate old hardware for running legacy software. Virtual machines are used to run programs incompatible with the host operating system. It allows test programs on multiple platforms and virtualize networks by running servers as virtual machines on physical clusters. When programs are compiled into machine code, that code will only run on processors with the same instruction set. Virtual machines can interpret intermediate code, allowing for cross-platform compatibility. To summarize, operating systems can be distributed, embedded, multitasking, multi-user, or real-time. BIOS loads the operating system at boot time. Device drivers enable the operating system to control hardware. And virtual machines emulate hardware through software, providing flexibility and compatibility across different platforms. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more content. See you next time.